Welcome to this geometric puzzle about a rectangle divided into 4 triangles. Given the perimeters of 3 triangles, we need to find the perimeter of the central triangle. At the heart of our problem is this rectangle. Let's label the corners of our rectangle with the letters A, B, C, and D. Each corner forms a right angle, which is fundamental to our rectangle. Internal lines divide our rectangle. Let's mark this point on the top edge as P1. Our second point, P2, sits on the right edge of the rectangle. For our third point, P3, it coincides with vertex D at the bottom left corner. Let's overlay a coordinate system to help with our solution. Here are our x and y axes. The internal lines divide our rectangle into 4 triangles. Let's look at this green triangle in the upper left. Next is this blue triangle in the upper right. The red triangle spans the lower section of our rectangle. At the center is our orange triangle, which connects all 3 key points. This is the triangle whose perimeter we need to find. Our rectangle has a width of 24 units and a height of 16 units. The green triangle has a perimeter of 48 units, the blue triangle 36 units, and the red triangle 56 units. Our challenge is to find the perimeter of the central orange triangle using only this information. Let's label the 3 sides of our orange triangle as A, B, and C. Now let's solve this algebraically. Let's call this top segment length x. Since the rectangle width is 24 units, the remaining top segment must be 24 minus x. Let's call this right segment length y. Since the rectangle height is 16 units, the remaining right segment is 16 minus y. The green triangle's perimeter equals 16 plus x plus a, which equals 48 units. The blue triangle's perimeter is 24 minus x plus y plus c, which equals 36 units. The red triangle's perimeter is 24 plus 16 minus y plus b, which equals 56 units. The key insight is to add all 3 equations together. Let's add the left sides of our 3 equations. The right sides add up to 48 plus 36 plus 56, which equals 140. Let's expand the left side by removing parentheses. Now we'll group similar terms, collecting A, B, C together, all constants together, and see what happens with x and y. Here's the magic. Both x and y terms cancel out completely. We're left with a plus b plus c plus 80. Our equation is now a plus b plus c plus 80 equals 140. Subtracting 80 from both sides, we get a plus b plus c equals 60. The perimeter of our orange triangle is exactly 60 units. The answer is 60 units. The beauty of this solution is how we found the perimeter without directly calculating each side length.